Let's say you've got a 1 meter per second flow rate of the canal flowing east, which it does. Assume east is the positive x direction. A boat with a weak motor is capable of traveling 1 meter per second in calm water. So the boat is just capable enough to match the speed of the flow of the canal. Let's say that the boat is turned around and is aimed due west, opposite of the flow rate of the canal. We want to describe what is reference frame S and what is reference frame S prime. I'll just draw it down here. We're talking about a canal where the flow rate of the water is to the right, but there's a boat pointed to the left. So west, east. All right. Now, reference frame S is a stationary frame, but neither of these frames is really stationary. I mean, they're both moving relative to each other. But what is reference frame S? That could be described as the reference frame I'll just call it of Earth. The bank, etc. It's my choice, like what I pick to be that reference frame S, but I feel like that's a good choice. All right, then we want to describe what is the reference frame S prime. So that would be the moving water. So let's say that there's a frog on a leaf that is just floating on the river. What reference frame would that frog be stationary relative to? All right, so the frog doesn't have motor, right? So here's his leaf. Big leaf, but here's the frog. What's he gonna do? Is he gonna stay stationary relative to a person who's on the bank? Or is he gonna move relative to that person on the bank? Because the person on the bank is in frame S, stationary frame. He's gonna move, right? He's going to just flow with the water. So that frog is actually stationary in frame S prime. And we could show how the frog moves. It's going to drift. Relative to like a bird's eye view, or a person on the dock's view. All right, so that frame that the frog is in is the frame of the water, and he's moving with the water, and so is his frame. That is the frame S prime. All right, but now it says a person who's sitting on a rock on the riverbank is stationary in what reference frame? That would be frame S. Now, if the frog on the leaf is just floating, what would the velocity of that frog be relative to Earth's frame? So I'm going to say V equals 1 meter per second I hat. Now V is the velocity relative to the stationary frame S. That's why I picked that letter. What what is the boat's velocity relative to a frog on a leaf who's just floating down the river? All right, so that would be v prime. And it would be negative 1 meter per second I. Now, why do I say that? There's a lot that goes into that. First of all, the boat is pointed opposite the flow. So the boat is like thinking that it's moving to the west, right? That's what its motor is trying to do. But the problem is that there's two things that are contributing to that boat's actual velocity relative to frame S. The boat has what he thinks he's doing, which is v prime, a velocity relative to a moving reference frame. But the other component of that is v frame. It is the velocity of the moving frame. And as the formula says, v equals v prime plus v frame. And this is, I'm talking about here, the velocity of the boat, though, not the velocity of the frog. See over here, this is the velocity of the frog. All right, so what ends up happening then is, if you were to plug the things in and find that velocity of the boat relative to the person who's sitting on the bank, you would have to add these together. So it ends up that it doesn't go anywhere. The final velocity relative to the bank would end up being 0. So that boat is just kind of sitting there motionless.